I was having a problem. Okay, now it's solved, I think. Okay. Let's see. Yeah, okay. The second one, gravitational acceleration on the surface of the planet of a radius r is g. The gravitational acceleration at the height of 3r above the surface of the same planet is?
Gravitational acceleration of the surface of Earth is okay. The gravitational acceleration, which is g. Will it not be? See. I think it's g over 60.
G over 60. 16. Okay, number 8.
Yes.
Okay, let's see if it's correct. Okay, the formula for G equals G M over R squared. Okay, that's fine. Gravitational acceleration doesn't change. The mass of the planet does not change. The only thing that is changing is the R squared. You agree?
Yes.
Okay, so the original R was R squared. This is what we had. And then the new one will be, we have been told that now the object is at a height of 3r. So what will be our new r?
It's gonna be 3r.
Unfortunately, it's gonna be 4r. It will be the height plus the radius.
Oh.
Do you agree?
Okay, yes.
Okay. So we have 4r in brackets and you square. Don't put 4 outside of the brackets. Okay? So we're gonna have G M all over 4 squared is gonna give you
16.
16 r squared. Yeah, you got it. You got it. Yes, because this is the value of G. G is equal to that. You agree? Okay. Yeah, I think you're not very good in these things. Okay, that's impressive. Although it sounded like you guessed because you said the value of R is 3.
No, I was just processing it in my head.
Oh, okay, but you must do these calculations as well, because you will get instances whereby the mass will also change. So you have to put the values as well. All right. The mass of the man on Earth is 85 kg. What will the mass of the same man be on the surface of a planet which has the same mass as Earth, but half the radius of Earth? Now they are catching you. It's the same principles.
Yeah. It's 8.5. The mass is 8.5.
Okay, the mass of the man on Earth was that. They said, what is the
Eight.
mass of?
On the
You said
surface.
the answer is C.
No, I didn't say the
Okay.
answer C. Which? Okay. That if I'm only given the mass of the man,
Yeah.
can I not use G is equals to GM over R squared?
Let's use it.
Okay. G equals to G, which is 6.67 times 10 upon 8 of 11 multiplied by 85 over half of Earth's radius, which would be 8. By 2. Okay, it's gonna be that. 3, 1. What are they looking for?
They're looking for the mass of the same. They're saying what is the mass of the same man on the surface of the planet? The planet which has the same mass as that of Earth, but half the radius.
Okay. Let me do this. 6.8 times 10 to the power. Let me do that. 85 times 10 to the power 6. Then be 8.9 times 1 to 16. Then I'm gonna use this. Which 10 to the power negative 11 divided by okay.
You can do a guesswork if you.
I'm about to guess because this is not working out.
Okay.
So I don't know. D.
Okay, D.
Yes.
Or did you do chemistry in grade 10?
Yes.
Do you remember calculating the molar mass?
Yes.
Okay. If you calculate the molar mass of H2O, if you calculate that molar mass on planet Earth, and then you go and calculate it on planet, say Jupiter, will they be different?
No. No, wait. Yes.
Will they be different?
Yes. So
Or are they gonna give you a new periodic table when you get to Jupiter?
no.
Okay, so what makes you think that the mass will change?
So the mass won't change.
The mass won't change. The definition of what is the definition of mass? Or let's say matter. What is matter?
I don't know what matter is, but I know what mass is.
Matter is everything that occupies the universe and has mass.
Okay.
And what is the definition of mass?
Mass is the amount of matter in an object.
Yes, is the amount of matter. So the amount of matter, let's say you have an 85 kilograms of wood, and that's the amount of matter. If you go and put it in another planet, will that amount of matter changes?
No, no, it will not change.
It won't.
Oh, I get what you're saying now. I get what you're saying.
Yes. So the only thing that changes is the gravitational acceleration g. And the other thing that changes because of the results of changing g is the weight. Your weight will be different on different planets because your weight depends on the gravitational acceleration, not your mass.
Okay.
Okay, so you understand?
Yeah, I understand now.
Okay, the answer is C. Okay. Yeah. If you go to another planet, your gravitational acceleration will be different, and so is your weight. No problem. Okay. An object is placed a distance r from the center of the planet, experience an attractive force F. Which one of the graphs below represents the relationship between force F and the distance r from the center of the planet?
B.
You said B. They are saying the relationship between F and the distance R. Okay.
Yeah.
Okay. So you're saying the answer is B. Okay. When R increases, does F increases?
No, I don't think so.
It decreases, right?
Yes.
But you said F.
Okay, yeah.
Oh, you said F, but wait. You may have a point. Let me see. When yeah, I agree with you. I agree with you. I agree with you because what they've put here is 1 over r squared.
That's good. Yes.
Not, yes. If they have put r, then the graph that we're going to talk about is this one. Okay. Okay. Let's go to the next one. Three forces acting on an object are in equilibrium. Which one of the vector diagrams below indicates the force in equilibrium? I think we have talked about this one.
Yes, we spoke about it.
Yes, which one is which?
Let me see. It has to be B. Yeah, it has to be B.
Yes, that's correct. That is correct. The head must be on the tail, and the tail must be on the head in any direction.
Yes.
Yes. Okay. Let's see. The 3 point charges of a magnitude 2 plus 2 microcoulombs plus 3 microcoulombs and plus 3 microcoulombs are placed in vacuum. Okay. To form a right angle as shown below. Now the net force acting on 2 microcoulomb can be represented by, this is very easy.
A.
A, you said A.
Mm-hmm.
Okay, let's see. This is our 2 microcoulombs, right?
Mm.
So when it interacts with 3, ne, where will it
Yes.
go? Where will it go when it's interacting with 3?
That way. When it's interacting with 3.
Yeah, with this one.
It will go downwards. Will it not?
Oh, okay. Are you, are you attracted to?
Oh, yeah, we spoke about this. No.
Okay. So where will it go?
So it'll go up because it's repelling.
Yeah, that's correct. It will go up. That's the first interaction. The second interaction,
Between uh if it's placed like that, won't it go down?
if
If
I
it's
remember,
repelling.
I remember you only deal with 2 charges at a time, and then you forget the other one. Ne?
Mm-hmm.
So we are checking the relationship between this one and this one.
They will repel from each other.
And then when 2 microcoulombs is being repelled, where will it go? Because that's what we are focusing on.
It'll go um to the this one to the left.
It will go to the left.
Mm-hmm.
That's correct. And then when we have 2 forces in
Uh,
this orientation, where is the resultant?
the resultant is going that way, so it's gonna be D.
That's correct. I thought it was gonna be easy peasy for you, eh?
No, it's
Oh,
not. It's
okay. No problem. Let's see. 2 identical spheres R and S on an insulated stands carrying a charge of plus Q and minus Q respectively are placed at distance R apart. The sphere R exert an electrostatic force of a magnitude F on S. The
mm-hmm.
2 I will think that there's a page I didn't put. Okay, it's fine. Okay. Does the teacher do multiple choice questions in class?
No,
Oh, okay.
we just do a lot of calculations and definitions.
Okay, no problem. Okay. Now, the magnitude of electrostatic force that sphere R exert on sphere S is, let's go back to the question. The 2 spheres are now brought into contact and are then returned to their original positions. The question
Yes.
now is the magnitude of electrostatic force that sphere R exert on sphere S is now
Can't be A.
okay.
It can't be. Mm. So I think it's B. B
B.
or,
B.
or B. Yes.
Okay. Let's see if it's B. Okay. Q nu is given by Q1 plus Q2
Two.
over 2.
Uh,
So
two. Sorry.
our Q1 is, let's go up. It is plus Q
Mm.
plus
Didn't
Q
consider the signs.
plus minus Q
Here.
divided by 2. So what do we have?
They have 0.
Okay.
I shouldn't consider the signs.
You have to
Oh
consider the
man.
sign. The other thing that you must consider also, is that a
Yes.
neutral object consists of the equal number of positives and negatives.
Yes.
So when the two charges which have the same magnitudes come into contact, they will form a neutral object. And then when you cut that neutral object into two, the two pieces will be neutral.
Yes.
Okay. That's another way of thinking of going about it. Okay. Consider the following vector diagram and answer the question. Which one of the vectors is the resultant of the other three vectors?
Oh wait. That is that. X, Y. Uh mm, I think it I think it's Z. No? No, W, W.
I think it's
W.
W.
Yes.
Okay. Can you substantiate?
Because Y and no, it can't be. If that's there are three vectors here.
Yeah.
That's hmm. I think that forms a triangle W and X would make a high degree angle.
Okay.
And
W and X forms
that. Yes. And
okay.
then what? Um okay. I don't know. I don't know where to
Okay.
go from here.
Okay. If I take X and Y, I will have the following. If I take X and Y, I will have something like that. My resultant will be going in that direction.
Mm-hmm. Mm-hmm.
You agree?
Yes.
This is Y, this is X. Then I'm gonna take my resultant and pair it with Z. I'm going to take it with its direction pointing, yes, something like that. And then Z is pointing in that direction. So if it's pointing in that direction, my resultant will be pointing. I took the resultant between X and Y, and then I paired it with Z, which is a vector. It gave me W. I know this is very tricky, right?
Yes, it's very tricky.
This is very, very, very tricky. And so, because if you pair W and X, your resultant will
Facing that way,
go in that way.
which wouldn't make sense.
Which wouldn't make sense. Okay, that's fine. Now, a girl which has a weight of 600 Newton is standing on a bathroom scale in a lift that is moving, and she noticed that the scale reads 660. Which one of the following is the correct conclusion about the motion of the lift? Which one is correct?
B. B? Yeah, I think it's B.
B, you're saying the lift is moving downwards. Okay. The question is, what is the weight on the scale? What does the weight reads on the scale? Which force does the scale reads?
The weight is 600.
Do you understand that the scale reads the normal force?
Oh yes, because yeah, I think I'm gonna get on.
Okay. Now they said the girl which has 600 newtons. That's what the scale is reading, right?
Yes.
And then the lift is moving, and she noticed that the scale reads 660. It means the normal force has increased. Okay. Let me draw a free body diagram. Let me give two scenarios. You are saying the acceleration is downwards. And
yes,
we have two forces. We have the force of gravity,
and we have normal force.
and we have normal force.
Yes.
Which one is big in order for your object to be going down?
In order for your object to be going down?
Yes.
Is it not your force of gravity?
Yes. This is the one that is, yes, that is big. But now, if the lift, let's say for instance, if you're on the lift, and the lift is moving downwards, are you gonna feel more pressure on your feet than when the lift is moving up? Because
When
the normal force is it's a reaction force.
Yes.
Okay, so when you're moving downwards or when you're moving upwards, Which one will give you more pressure on the feet?
When you're moving upwards, you'll feel more pressure on your feet compared to when you're moving downwards.
Hence, B is not correct.
Okay.
If you are feeling a lot of pressure on your feet, it means your scale will be squashed even more, and the reading will increase to 660.
Oh, so that
The
means,
scale is pushing you upwards.
okay.
So therefore, the acceleration is upwards.
Okay.
Do you remember the concept that we have talked about, the concept of weightlessness?
Yes.
Did you do it in class?
Yes. Yes.
Okay.
Yes. Yes.
Okay. I can guarantee you that if if the belts inside the lift breaks, né? And then the lift starts moving in a free fall. If it starts moving in a free fall and you're on top of a scale, the scale will read 0.
Yes.
Do you understand? Why
Yes, I understand.
is the scale 0?
Because you're you're what? There are no, what did I want to say? Oh, you're feeling a lot of acceleration pulling you downwards.
Not really. The correct answer is because you will be accelerating in the same acceleration as the lift.
Okay.
Therefore, you guys won't catch each other.
Oh.
Yes.
Also,
So
which explains weightlessness then, because no
it,
external forces are acting.
yes, you won't be in contact because you are trying to run after one another, but you are accelerating at the same acceleration.
Okay.
Yes. Yes. If you are running after someone and as soon as you increase the speed, then they increase the same, they increase with the same speed, you won't catch them. There won't be
Yes,
contact.
sir.
Yes. All right.
Mm-hmm.
So the answer is D. Do you agree with it?
Yes.
Okay. The passenger is moving. The passenger in a moving car are advised to wear a safety belt. This will reduce their chances of getting injured in the event of an accident. This precaution is an application of one of the following physics laws. I know you know this one by head.
I don't think I know it.
You know, I know.
Reduce their chances of getting injured. I think it would be A.
Uh, Reduces the chances of getting injured in the event of an accident.
If it's not
This precaution is an is an application of
an
Newton's
application. Oh. So let me
Newton's
explain
yes.
why I say A.
Yeah.
Because uh when I think of Newton's first law, what comes to mind is inertia, which is the resistance of any body to change its the resistance of a body to any change in its state of motion. So if the car, like for instance, brakes, then the body will want to keep on accelerating, not accelerating, but moving in the way, in the direction in which it was moving at.
That's why I told you that you know the answer very well. And that's it. The answer
Oh,
is A. Yes. The person was going
okay.
to continue to move in the same direction with the same speed unless a resultant force acts on it. So
Yes.
the belt introduced a resultant force. You actually know the
Yes.
answer, and the answer is A.
Mm.
The answer is A. They can also ask you to say, okay, well, they can ask you to say, if the force that the man exert on the belt is F, what will be the force that the belt exert on the man?
It will also be F, but in the opposite direction.
Oh yeah, that's correct. Now I see why you say you have mastered Newton's law. I see. It's a good thing. It's a good thing. So let me bring a practical question. I know you have also mastered the gravitational law.
Yeah.
Okay, now that one is easy. Two formulas, that's it.
Yes.
And don't forget to consider the radius.
Yes, sir.
But if you're dealing with a small object, you don't have to worry about the radius because it's extremely small.
Yeah. There was actually a question we did in class that in the question they only told us about the radius of yeah, well, the distance between the planet and the surface of the earth. And that question was tricky for a lot of us because we did not know that we are actually supposed to use the radius of the earth and not the that they were supposed to add the distance of that object with earth and the radius of earth.
Oh, the distance from the surface.
Yes, the distance from the surface.
And yes, yes. So yeah, you must always bear in mind that we are talking about the centers of the objects, not the distance between them.
Yes.
Yes. The same apply with charges.
Yes, sir.
Okay. Do you see what's on the screen?
Yes.
Okay. Now, two identical point charges are placed 10 millimeters apart in a vacuum, as shown below. The electrostatic force that Q1 exerts on Q2 is 8 newtons. Okay,
Mm-hmm.
that's good. And then they said, draw the electric field between the two charges. So can you choose between the two?
Okay.
Let me finish it up. Which one is correct? A or B?
A. A is correct.
A is correct. Okay.
Mhm.
State the Coulomb's law in words.
The magnitude of electrostatic force exerted by 2 point charges on each other is directly proportional to the product of the magnitudes of the charges and inversely proportional to the square distance between them.
the square of their distance. That's perfect. Or you can even say the square of the distance between their centers. And that's also very precise, but it's fine. Calculate the magnitude of each charge.
Of each charge.
Yeah.
Okay.
The
electrostatic force that is 8 newtons.
Yeah.
So F is 8, right?
F is 8.
F is 8.
Is 6.3 next. 6.3. Let's see. 6.3. Yes. F is 8 and Q1 is.
Q1 is. Did they say? I don't think they said.
They did, and I think I've given you guys this question before.
I said, why don't I remember?
Or something similar.
8. They did not say.
Two identical point charges. They are identical.
Okay, but then if they're identical, they, but I don't know the magnitude of the charges, that's what I'm looking for, right?
Yes.
Okay. So then can I use? Yeah, I think I don't know.
Okay. So if Q1 equals Q, what will be the value of Q2?
Is it not Q if Q1 equals to Q2?
No, if Q1 equals Q, then what is the value of Q2?
Is it not 2 times Q?
2 times Q. Why is it 2 times Q?
Because they are two. No, but if they're identical, then that means Q2 is also equals to Q.
Exactly. So Q2 is also equals to Q. Okay, let me go and put Q. Let me write the formula properly so that you don't accuse me of not writing the formula. Okay, so 8 equals Q times Q all over. What is the distance between them?
It's 10 millimeters, so it's gonna be.
Which is. Is it correct?
Yeah. Yes.
So this will be Q. Can we multiply the two?
Can we multiply?
Q and Q.
Yes.
How much do you get?
You're gonna get Q squared.
Okay. All over. What do we get here?
Good. 1 times 10 to the power -4. My calculator is in times. 1 times 10 to the power -4.
1 times 10 to the power of -4. That's not bad. Is equals to 8. 8 over 1. You agree? So cross multiplication, we have q squared equals 8 times 1 times 10 to the power of minus 4. So this will give us 8.
So I have a question.
Yes.
What happened to the K?
Oh, you're right. Ish. Yes, ish, you are right. You are right. Okay. Okay, so this will be times, you agree it is going to be times 10, it's gonna be 9 times 10 to the power of 9, right?
Yes.
Okay, so what do we get if you divide that divided by that?
Power. You're gonna get 9 times 10 to the power 13.
Okay, so 8 equals, you said 9 times 10 to the power of 13 q squared. Then we'll divide by 9 times 10 to the power of 13, both sides.
8.89 times 10 to the power negative 14.
It's 8 times
8.89
times
10 to the power negative 14. And our answer is gonna be 2.98 times 10 to the power negative 7.
Okay, so you're saying q is gonna be you applied the square root, right?
Yes.
It's gonna be
2.98
times 10 to the power
negative 7.
Wrong.
Why? What happened?
Plus or minus.
Oh,
Don't forget. Yeah.
yes.
So it's plus or minus. So the two forces can, the two charges can either be minus and minus or plus and plus. You agree?
Yes.
Okay. Coulombs. Okay, no problem. Because you're gonna lose marks if you don't show the signs. Okay. Yeah. Now define the electric field at a point. What is the electric field at a point?
Electric field at a point.
Yeah.
The is the electrostatic force experienced per unit positive charge placed at that point.
That is correct.
Oh, okay.
It is the force per unit charge of the test charge. Test charge. That is why the day when we were drawing the field lines, I said, where will your positive test charge go if you place it next to a host charge? So the unit test charge is the positive test charge of the yeah, you can even emphasize of the positive test charge.
Okay.
Test charge around charged object. Fine. Okay, you can define it in whatever way, but if you can define that electric field equals F over Q, this is exactly what you're defining. Yeah. Okay. Do you remember this formula though?
Yes.
Yeah, it's per unit charge.
Yes.
Okay. Calculate the net electric field at point P as shown in the diagram below.
The net electric field at point P.
Yes.
So I would use. Okay. I would first calculate I'll first calculate the electric field of point, right? Yeah, I'll first calculate the electric field of point Q1, basically. And then the electric field of Q. No, something is wrong. No.
Okay.
E is equals to. Yeah, I'll first calculate the electric field at Q1 and then calculate the electric field at Q2. And then
electric field at P due to
Q1, yes.
And electric field at P due to
Q2.
Yes. Okay.
Which would then be so since we calculated the magnitude of the charges, right?
Yes.
We can use that. But now, okay, they're both positive, so I'm assuming that that's what we can use.
So here I forgot to say, okay, Q equals plus 2.98. Yeah, thanks for the reminder. Okay. So they're both, yeah. So we're gonna have the formula will be E total will be
KQ over R squared.
KQ 1 over R squared
plus KQ2 over R squared.
Plus KQ2 over R squared. Okay. So you remember what we were discussing, when was it? On Tuesday. I said, if you put a test charge here, because we are dealing with vectors, let us choose directions. Which direction do you want to choose as positive?
My right.
You're right. Okay. Let's see the interaction between Q1 and P. Where will the point charge go? To the left or to the right?
Between Q1 and
Q1,
P.
yes.
I think to the left.
Okay. Positive will attract positive. I think that's what you're saying.
Oh no. Oh, which side do? Oh yes, no, to the right, to the right, to the right. I chose to the right as my thing. Yeah.
Okay, so to the right, E1, and then the interaction between Q2 and P. Where
It'll
will
be in
P
this
go? It will be
in the same direction.
in the same direction.
Yes.
So I agree with you with the formula that you gave me. It's gonna be a positive, the plus. Okay. So we're just gonna replace the figures times Q1 is
2.98 times 10 to the power negative 7.
then plus 9 times 10 to the power of 9 times 2 times 9, 8 times 10 to the power of minus 7. All this one is over. We can say all over if we want to, but let me try to be politically correct. Oh no, we can't say, yeah, no, we can't because there's different values of R. Sorry. Okay.
Yes.
The R for Q1 is, let's go back to the diagram. It is how much?
So then it would be it's gonna be 0.01 plus
0.01. Let me see. 0.01. You said plus.
plus.
No problem.
Because what's the second one? Wait, so I'll tell you now. It's gonna be 5 times 10 to the power negative 3.
Okay, can you write it? Is that it?
Squared.
Word. Okay. Then this other one will be the value of R.
0.005 squared. That's it.
Now let's see what we're gonna get.
2.98 10 over 7 over 0.1. No. Yeah. Okay. Then I'm gonna get 1, 5, 4, 1, 2, plus 9, 2.98 times 10 to the power negative 7 over 0.005 squared. Okay. Huh? Yeah. And then, okay. And then it's gonna be 1, 2 plus Am I doing the correct thing? Yeah, I am. It's 1,19 times 10 to the power 8.
1,19 times 10 to the power of
8.
8. The units?
It's newtons per coulomb.
Okay,
Alright.
newtons per coulombs. Okay. Okay. Let's see what the next question says. The next question says, a third charge Q3 of a magnitude that is now placed at P. As shown in the diagram. Calculate the net electrostatic force experienced by the point charge Q3 due to point charge Q1 and Q2. 3 marks.
So what's the question? A third charge of magnitude
5
microcoulombs is placed at point P shown in the diagram. Okay. Calculate the electrostatic force by point charge Q due to the electrostatic force experienced by point charge Q3, okay, which is okay, due to point charge Q1 and Q2. Aren't we going to use F is equals to K Q1 Q2 over R squared, but for both, like,
Yeah.
for both scenarios.
I agree with you. So F total equals F1. Okay. Do you agree that in both interactions, the electrostatic force due to Q1 will be in that direction, and also the electrostatic force due to Q2. You agree?
Yes, I agree.
So both of them will be a plus. Okay, so this will be 9 times 10 to the power of 9 times times 2.98 times 10 to the power of minus 7.
6.
Then
so
times
6.
Do you see?
Oh, yes. No, sorry, my bad.
Yeah. Okay. Times 5 times 10 to the power of minus a micro is 6. Yeah, I agree with you on this one. Then divided by the distance that you gave me initially was 0.01 plus 0.005 squared. Right? And then plus 9 times 10 to the power of 9 into the other one is also the same, 2.98 times 10 to the power of minus 7 times 5 times 10 to the power of minus 6 divided by the distance is 0,005 squared. Let's see what we're gonna get.
Yeah. See. Okay. And it will be wait. 96. The answer is going to be 5.96
Okay,
times
5.96 times
10 to the power of 2.
10 to the power of 2. And the units?
The unit is going to be newtons.
Newtons. Okay, that's another way of going about it. Okay, what is the definition of electric field?
Electric field is a region. Oh yeah, it's a region in space where an electric charge experiences a force.
Okay. What is the definition of the electric field strength experienced by a charge?
Electric field strength experienced by a charge is E. Is it not that it's the force that is experienced per unit? Is the electrostatic force that is experienced per unit positive charge placed at a point?
Yeah.
Oh, now we can, okay.
You see?
Yeah, I see.
The value of E was, if I'm not mistaken, we have already calculated it. That's actually what they wanted you to do. They wanted you to use.
I was wondering why I had to do all of this for 3 marks.
Yeah, true. So the marks will show how much effort you need to do. Yes. So your point charge, it is the charge that has been introduced. It's not the host charge, it is a charge that has been introduced, or the test charge. In the question, which one is the test charge? Let's see.
Is it not 5 microcoulombs?
Yes. Yes. So divided by 5 times 10 to the power of minus 6. So if you cross multiply, your F will be 1 times 19 times 10 to the power of 8 times 5 times 10 to the power of minus 6. So how much will you get?
You are gonna get 5.95 times 10 to the power of 2, which is like almost there.
The same.
Yeah.
So when you get to your exams, you must bear in mind that E has 2 different formulas. The first one is KQ over R squared, whereby the Q that you have there is the Q of the host.
Mm-hmm.
And then E is also equals to F over Q. And the Q is the Q of
the test charge.
the test charge. Yes. The charge that has been introduced. So the units will be the same. It will be newtons. So before we end, I just want to do quick rapid fire questions to see where you are.
Mm-hmm.
What is electrostatic? What is electrostatics?
Electrostatics is, I did this yesterday. It's that, isn't it all charges in the universe? Or the force that charges in the universe exerts on each other?
No, electrostatics. Electrostatics. It is electricity created by charges at rest.
Be created by charges at the rest. Okay.
Statics. The word statics means stationary or at rest.
Mm-hmm.
Okay. What is the formula of calculating the electric field strength?
Electric field strength, it E is equals to KQ over R squared.
And the other one?
E is equals to F over Q.
Okay, perfect. Can you state Newton's second law?
Newton's second law states that when a resultant or net force acts on an object, the object will accelerate in the direction of the force at an acceleration that is directly proportional to the force and inversely proportional to the mass of the object.
Okay, that's perfect. Does forces that are not forces that are not in equilibrium form a stable triangle?
No.
Okay, that's correct. And will forces that are more than 3 form a triangle?
No.
Okay. Okay, yes, that's correct. The other one is, okay, can you state the gravitational law?
Which one? Newton's gravitational law?
Yeah.
What? Okay. Newton's gravitational law states that each particle in the universe attracts every other particle with a gravitational force that is directly proportional to the product of the masses and inversely proportional to the squared distance between their centers.
Yes, perfect. Perfect. The other one that is tricky, the other one that they can trick you with is okay. Oh, the other thing that I wanted you to note, is that
Yes.
in grade 11, you're only gonna be dealing with identical spheres.
Yes.
Yes, it's
So
only gonna be identical spheres. The other thing is question number 2 may come again. No, question number 6.3 may come again. Please don't forget to interpret what has been given. For instance, if they say two identical point charges, identical point charges, you will know that if you have Q1 and Q2, you can replace both of them with Q. Ne?
Yes, sir.
They can also give you a scenario whereby they say two unidentical charges. What does that mean? It means the other one will be Q and then the other one will be
negative Q
minus Q. And then you put it in the formula, then you solve for the value of Q.
Okay.
Then you get your answer. In Newton's law, you must bear in mind with your directions.
Yes.
You must choose your directions carefully. Yes, and then if they bring a question of weightlessness, how many days are you guys left with to write physics?
Today is Thursday. I have Friday, Saturday, Sunday, Monday, Tuesday. 5 days before my paper.
Okay, we will be able to attend the Tuesday class because I wanted to do an example on weightlessness.
Yes, I'll be able to attend.
Yes, because you never know. They may want to trick you. Because they know if they bring it in the test, half of the class may not get it.
Yes.
Yeah, because it's a bit tricky. Yeah, so I want you to attend the Tuesday class so we can do a question on weightlessness.
Yes, sir.
All right, so I'll see you on Tuesday next week.
Tuesday.
Yes, all right.
Bye.
Bye.